Greetings, comrades! This is everything Caleb back with another Universe Sandbox video, and yeah, you probably can't tell, I'm actually using my 8-bit DOE keyboard and mouse, the Xbox theme ones, because I just felt like it. Just like to switch around keyboards every now and then, even though it doesn't fit with my black and blue setup here. But anyway, so for this video, I figured I'd try something different. What we're going to do is mess the sun. Good old soul. We're going to do a few different things here. First thing I want to do is, well, as you can see, the sun is pretty much of helium and hydrogen. But what would happen if we made the sun comprised of different elements? Well, we're about to find out. As you can see here, yeah, it's not much of an atmosphere or ocean, it's just helium and hydrogen. Though, yeah, you have to pretty much go to show off if you want to add stuff to it. So, we have everything slow down here. So we can add a few different elements here. We got iron, silicate, argon, sulfur dioxide, oxygen, carbon dioxide, water, nitrogen, ammonia, and methane, as well as helium and hydrogen here. So, what I kind of want to do is tour around the different material compositions and see what happens to the sun and everything that orbits it. So we're at, so it's about, let's say 26% helium, 73% hydrogen. Or 74% hydrogen if we're rounding out. So, we're going to start with hydrogen first. I want to increase that amount and see what happens. And then we'll go to helium, then we'll start adding the other materials here. And instead of like jumping like straight to the top, we're just going to gradually increase it. I'm not sure if Greystone Plays did this. He probably did. He has like hundreds of Sandbox videos. A lot of them involving destroying Earth, among other things. So, yeah. This is just me doing it, see what happens. So, let's increase the amount of hydrogen it has. Okay, looks like, actually I didn't pay attention to the surface temperatures. Oh god, yeah, the, oh boy, I was not expecting that. Apparently adding a little hydrogen to the sun jump-started the, core temperatures of like 15 million degrees. Oh my god, what did it do to Earth? Nothing it seems. Oh, well, the core temperature seems to be the same. What about the surface temperature? It's like... I kinda I think by doing that, I changed the, temperature. The average temperature to 44 degrees. Max temperature 69 degrees. So yeah, it's gonna be fall weather all year round. Just the way I like it. See what's done to the surface. Doesn't look like much. Okay. Naturally, I imagine screwing with the sun will have adverse effects to everything around it. So let's go back to the sun. Let's go ahead and add a little more. Yeah, let's add a little more hydrogen to the mix. Oh, I noticed it increased the helium a bit too. So now we're at 2.52 solar mass of hydrogen. And the helium kind of dropped to 1.114. Okay, how about that? Did that do anything to Earth? Let's see, it's surprisingly still the same. Though it's, assuming he's going to Celsius. Okay, it's gotten a little warmer. And the sun is... Now it's at 20 million degrees Celsius. or 37 million degrees Fahrenheit. Yeah, I don't think any of us is running on that. Let's go ahead and keep adding. You know, I'm feeling like, oh, let's double the amount of hydrogen. Now it jumped up to 46 million degrees Fahrenheit. It doesn't seem to be increasing in size. It's increasing in mass. Oh, now it's like 20 solar masses bigger. And the 73 billion degrees Fahrenheit in this core. How's Earth looking? Are we dying yet? We're still surprisingly the same. Like, it's still 92.2% life likelihood. Well, to be fair, it's not that huge of a jump. In fact, it's hardly moved at all, actually. Because the sun... How's the temperature here? Still 5780 degrees or Kelvin, or 9,944 degrees Fahrenheit for us American folks. Wait, what's the planet orbiting? What's this? Hold on, what's this trajectory here? Is it? Oh, it's... Oh! We just lost Mercury. Okay. Apparently increasing the hydrogen composition of the sun is jacking up the orbits. Now everything's moving towards the sun. It jacked up Venus's orbit. And... yeah, everyone else is dead. Or will be dead soon. Okay, look at that trajectory path for Earth there. Okay, Venus is like falling apart. We got a bunch of fragments of Venus flying off. And we just... It's not quite a black hole, but it's jacked everything up. Okay, let's increase it some more, see what happens. Okay, now everything's getting more jacked up. Now we're at 80 solar masses of hydrogen on the sun. What's the temperature like? It's got a little hotter, 10,000 degrees. It's getting hotter. Oh, and we just turned the sun to a black hole. Apparently, putting too much hydrogen in the sun turns it into a black hole. Well, we learned something new. I'm not sure how it works in real life, but hey. I hope we don't find out. So that was just hydrogen. What happens if we, yeah, we're going to decrease to like, almost a day a second. So you can see some movement. Okay, so we just toyed with hydrogen. Oh, they didn't make the sun that much hotter, just like up by 1,000 degrees. It did make the sun heavier. Like we pretty much multiplied the mass of the sun by 20 thanks to the hydrogen. It pretty much turned it into a magnet for all the planets and asteroids around it. But what if we toy with the helium content? So let's gradually increase it a bit. Oh, jeez. Okay, kind of does the same thing. Apparently adding any of this stuff will make it, like, a magnet. We just lost Earth. We're all dead. Yeah, but pretty much comprising anything in the sun will make it heavier and it'll just draw everything towards it. And 300 solar masses of helium. 3,000. Now is a black hole without actually being a black hole. Oh, now it is black hole. Okay, so I think it's safe to say any material to the sun in large amounts will turn into a black hole. So I guess we got the gist of that. But I'm curious, what elements will increase the temperature of the sun? That's what I want to know. I didn't even check helium, because it was just going too fast. So, it's only comprised of helium and hydrogen, nothing else. What if we added iron? Let's do 1 solar mass. And just halved that. Yep, temperature's still the same. I'm not sure how that affected Earth. Looks like, 92% life likelihood. All because we, added some iron to the sun. Oh, it's gone up a little bit, okay. Okay, so what about... we double that. I don't think it's jacking anything up yet. Yeah, temperature's still the same. Okay, let's just add some other elements to it. How about some silicate? Not sure what that'll do. Okay, we jacked up mercury. Okay, everything's getting closer to... okay, adding iron and silicate to the sun also jacks up the... the temperature's still the same, though. And Earth, we are... yeah, we're starting to lose some people, yeah. Oh, we almost had a collision with Mars. Oh, Jesus. Okay, let's go ahead and, let's double the amount of iron we have on the sun, see what happens. Okay. It's checking up a little more. Venus is going, it's making a large hairpin turn there. Earth is, yeah, also doing some weird circles around, and, yeah, everyone's dying. As we expected. Okay, a bunch of asteroids flying everywhere. Okay, Mars is slowing down. Let's zoom out a little bit. Okay, Jupiter's kind of closing in a bit. Saturn's kind of... yeah, Jupiter's made a hairpin turn around the sun. Looks like Saturn's joining in the fun. Uranus is slowly turning in. And Neptune's kind of slowly turning in. There's Pluto. Yeah, we just completely jacked up the solar system doing this. And... yeah, Earth's just going on a merry-go-round. Yeah, pretty much everyone else is dead other than some, like, parameciums and, you know, bacteria and the what little water there is left. How is Earth looking? Let's check the, yeah, it's pretty much just a giant ball of white. But, turn off the atmosphere. Oh, yeah, it's... yeah, pretty much, almost looks like Mars now. Even though, yeah, Mars is a bit more red than this. Yeah, yeah, humanity's pretty much cooked. We're all gone. Yeah. All because it added a little iron and silicate to the sun. But the temperature's untouched, surprisingly. Though the core temperature is like 29 million degrees Fahrenheit. Okay, so that... Okay, that's iron and silicate. Let's check the vanilla sun before we start messing with things. There's the sun itself. Again, core temperatures always 29 million degrees. Okay, so that's a baseline, and 5780 Kelvin. Okay, so we did iron and silicate, but what about argon? What will argon do to the sun? Half that amount, apparently. Temperature's still the same. Core temperature's still the same. Okay. And some more argon. Now we're at 1 solar mass. Everything's, Okay, once again we're jacking up the... So, Earth almost collided with Venus there. Yeah, we're not messing with the Earth itself, but just jacking up the sun in different ways is definitely messing with its equilibrium. See, orbit's a bit closer now, and every time it makes that orbit there, it takes some life away, you know, give and take. Want more sun? Yeah, we get some. Give me some of your life force as well. Yeah, Mercury's closer. Almost had a collision with Venus there. Okay, Mars is joining in on the action here. Yeah, life on Mars is slowly deteriorating. Just because I added some argon to the sun's mass. Well, we're looking for anything. Adding any more mass to the sun will cause the planets to lose their equilibrium. Like their normal orbits, like non-existent now. They're just closing on the sun certain ways. Oh God! Venus almost had a collision with Mercury. Almost had a collision with Mars as well. Okay, let's increase the argon amount. Oh yeah, we jacked up Mercury's orbit, now it's even closer to the sun. It's nearly having a collision with Venus. That'd be a scary prospect, a planet colliding with another planet. Yeah, all the orbits are jacked up. Mars is going like an oval now. Is that an elliptical orbit? I think that's what it's called, I don't know. Yeah, Earth's kind of doing its thing. See, the farther it is from the sun, the slower the orbit is, but as soon as you get closer, it's like zips around. I'm trying to get to Earth there. How's the life on Earth? Yeah, not too great. Okay, something flew into the sun. Guess a stray. I don't know what that is. It's like a little trail or something. Okay. Let's, Okay, I just, halved that, and now all the planets are flying away. Did I restore their orbit? Not really. Doubled that. Yeah, Earth's like going like super fast. I don't think anything's alive now. Where's Mercury? I think it got absorbed by the sun. Venus is making some close calls. It has the closest like orbit to the sun here. Earth right behind it, and Mars. Earth is still surprisingly circular. Almost a perfect circle. Almost. You know, it's more like an oval, but... I don't think anything's alive now. Yeah, just like some, like, bacteria. Okay, so I'm not gonna go crazy adding minerals and stuff, though, because we don't know adding too much will turn into a black hole, apparently. But apparently adding any amount to this will cause a Orbis to jack up. Okay, so we just did argon. Okay, I'll leave it at normal speed this time. And we're actually look up here. You can see Mercury's a perfect circle, but it's not like center with the sun. All the other planets are. So what happens if we add sulfur dioxide to the sun? Let's see what happens. Everything's about the same, okay. What if we added more? Let's just do a gradual, like, increase. Okay, the orbits are getting a little weird now. Yeah, Mercury's just kind of the same, only a bit smaller. Yeah, Venus and Earth. Oh man, Venus and Earth's. Actually, all the planets' orbits are getting weird. You can see Venus's orbit is now intersecting with Earth's. I'm not sure if they're gonna have a collision or not. Oh, it came close. You barely see that. Earth is somehow gaining life. That won't be the case for long when we add some more sulfur dioxide to the sun. Okay, it's getting more ejected. Oh! Because, okay, Earth is, also has some collisions with some asteroids there. Hey, did I, Okay, Mars is, like, going on vacation now. It's, like, gone. Like, I'm out of here. See ya. Yeah, Mercury's still circling the sun like nothing. Yeah, Earth's, orbit's jacked up again. So is Venus. Right here we have a three-way intersection between Mercury, Venus, and Earth. I'm pretty sure they'll have a collision at some point. Speeding up, let's see if it does have a collision. Doesn't look like it. Pretty sure Earth's still... Or surprisingly, still have a 75% chance of life on Earth. Okay, so apparently getting close to the sun increases the life likelihood. But the core temperature is pretty much the same, as well as the surface temperature. So apparently adding mass to the sun doesn't really, Oh, I noticed there's a trail on the sun. That means it's moving. Okay, the sun itself is moving. What happens if we increase the sulfur dioxide a bit more? Oh god, Mercury. Oh, Jesus. See, Mercury's like closing in on the sun. Look at that. Oh, let's slow down this a little. Let's slow this down a bit. Oh god, yeah, Mercury's close to the sun as it can be. Yeah, Venus is all. I don't want to say just Venus and Earth. All the orbits are getting jacked up. Might do this at a higher zoom. Okay, Earth is not doing so hot. What's the Average of 91 degrees. Again, it's heating up. But minimum temperature is cooling down like a lot. Max temperature 135 degrees. Okay. Now it's summer all year round. And life expectancy is surprisingly only a little worse. We had some sulfur dioxide to the sun, and we took out 30% of life on Earth. Okay. I think I have a good gist of what happens when you add anything to the sun. It obviously makes the sun heavier, and it pretty much gives it a stronger gravitational pull that pulls over the planets around it and jacks up their orbit to unbelievable things. Okay, so we have all these. Here's Sedna, the largest orbit around the solar system. Okay, so we're actually going to zoom out this time just to see what happens. We're going to leave it at normal speed. And sulfur dioxide. What about oxygen? Add a bit more oxygen. Okay, it's pulling everything in. Okay, we just lost the inner planets. Jupiter's getting sucked in. See a bunch of like, as far as Ceres is gone, Saturn. Okay, Jupiter's got launched out. Okay. Okay, Jupiter's like turned into a red hot pinball there. Planet flying by sun. Of course, I don't be lying, it's a gas giant. But yeah, Jupiter's glowing red. You see that? I'm trying to zoom in on Jupiter. Oh my god, look at that! Imagine if scientists saw Jupiter look like this. They'll think it's like another sun being birthed in the middle of our solar system. And what about Saturn? It was getting all jacked up as well. I know Saturn lost its rings. I guess the sun took them. Okay, Uranus is jacked as well. Okay. Guys, well, I notice as soon as a planet gets close to the sun, it turns like super hot red, then it flies away, it turns normal. But Saturn, yeah, Saturn's gone. Jupiter is flying away now. What happened to Jupiter? Oh my god, is that what Jupiter looks like without the gases around it? Oh man. That is crazy. I literally thought gas giants looked like giant, just that, giant balls of gas. Apparently there's some solid surface on Jupiter. Well, I can't see Saturn because Saturn's gone. Uranus. I guess circle back around the sun. Okay, Jupiter's going away from the sun now. Everything else is going towards it. Yeah, Neptune just turned hot red. I imagine if we increase the mass a little more, then Jupiter will come back and just fly towards the sun. Okay. Yeah, it absorbed Mercury, Venus, Earth, and Mars, and Saturn. So now it has like more stuff to it. It has some iron, silicate, oxygen, and water, and nitrogen. Jupiter's going like, Jupiter wants none of that. Well, you can get some anyway. How's the surface now? It's not that much hotter, honestly. Despite having 5 planets collide with it. And countless, like, asteroids and stuff. It didn't make it much hotter. Core temperature's still the same. Let's go and add some more oxygen. Let's double the oxygen, how about that? Is Jupiter still flying away? Yeah, Jupiter's still flying away. Everyone else is, like, getting sucked into the sun. Okay, I only see Neptune and Pluto now. Now Sedna's getting sucked in. Chiron's flying away. Yeah, look at all these asteroids and stuff. It's like a protons and electrons flying around. It's like trying to make an atom, but it's failing. And yeah, the sun's moving. More oxygen. Yeah, Pluto's just doing jump ropes around the sun. Okay, Haumea, Quoar are getting sucked back in. Jupiter's still flying away along with Chiron. And what's that over there? Oh, just fragments of whatever. It's not a black hole, but it's like sucking everything in and like superheating it. It's still not that much hotter. Double that. Yeah, it's not making it that much hotter. The core temperature and the surface temperature is still the same. Again, despite having 5 planets and countless asteroids crashing into it, and the increasing amount of oxygen it has. Okay, Pluto's flying away, I think. Yeah, Jupiter's still way out there now. Oh god, a fire that's shooting at super fast speeds. Jesus. I'm pretty sure adding more will turn to another black hole. 28,000 solar masses of oxygen. The core temperature is still the same. Yeah, the core temperature and surface is still the same. Now everything's flying away from the sun. So Jupiter and Pluto are the only 2 surviving planets. Like all these other asteroids. Orcus is flying away, Make, Make, how do you pronounce that? Gong Gong. Chiron. Okay, actually slow down the trajectory. But if we decrease the trajectory, yeah, everything's flying away now. We got 70,000 black hole time. Oh, Jupiter's coming back and it's getting sucked up. Oh man. I thought adding like different elements would have like different effects, but it seems to be the similar effects. Like everything gets pulled towards the sun, and if you put way too much of a solar mass into something, it'll turn to a black hole. I'm trying to figure out what will make the sun get hotter. Carbon dioxide? Let's go 2 solar masses. Jump straight into it. Okay, no significant changes. I was gonna gradually increase it. Let's try that. Okay, everything's getting jacked up now. Okay, apparently adding carbon dioxide Seems to have stronger effects on the orbits and stuff. And there goes the inner planets. Okay, this experiment's been eventful, but I was expecting a little more variety. I was hoping all this stuff would jack up the temperature and stuff, but... like, only if I go crazy does anything significant happen. It's just everything getting driven to the sun. I'm trying to figure out what will increase the temperature. And also we try with, like, hydrogen and helium. Yeah, it's not jumping up that much. Everything's like flying away. It looks like Neptune and Pluto are the only surviving planets. Everything else is like absorbed into the sun. There's a bunch of stray asteroids like circling around it. Okay, well, let's try one more. This time we're gonna go all out. We're gonna add a bit of everything to the sun. Okay. We'll double the hydrogen, double the helium. Now add some iron, some silicate, some argon, sulfur dioxide, oxygen, carbon dioxide, water, nitrogen, ammonia, and methane. And I'm already seeing, oh my god, it's like... I perhaps term Mercury to Usain Bolt. There's Earth, yeah, pretty much, Yeah, I don't think anything's surviving that temperature, don't you think? And apparently the game agrees, only 0.2% likelihood of life. Again, probably some amoebas or stuff in the Donakill Depression in Africa. Okay, so the sun has a little bit of everything now. Temperature's still the same. Core temperature's still the same. Okay, it doesn't actually affect the sun itself, but rather everything else around it. Because I know we've experimented earlier, it actually increased the surface temperature and whatnot. But here it's not doing so much. Add new materials. Like what? I don't... I guess you add your own materials. I don't know how though. Okay, let's just, you know, let's double everything just to see what will happen. Obviously, everything's gonna get jacked up. Yeah, doubling everything. No, not 200, 2. Oh my god, imagine zooming out the source of it, it looks like this. How's life on Earth? Yeah, pretty much non-existent. Surface... yeah, Venus is glowing red hot, Jesus. Yeah, it looks like a Venus. Surface is like, yep, 3,000 degrees Celsius, average temperature. Minimum temperature 1,200 degrees, a little cooler. Yeah, I don't think anything's gonna survive out there. But I can't say Earth's much better. Yeah, let's yeah, Earth's like it's trying to become a sun. I'm not sure what's gonna happen. That is crazy. It seems here does the sun get bigger? Well, I did like double its like solar mass and like all this stuff. Yeah, I think it's gotten bigger. Let's double this to 4 solar masses of stuff. Hell, it's getting heavier. No, the size is the same. Radius is still 1 sun, but it's getting heavier. It's like 45 times its mass, but the temperature's still the same. It's crazy. Okay, can it does like mass? See, that's crazy. Okay, one more experiment. This time we're just gonna add water to the sun, see what happens. Okay, show. Okay, water. Let's turn the heat ball to a giant water ball. He's jacking up mercury again. I saw some like activity happen on the sun. Well, if you add a lot of water to it, it does not make a difference. Okay. I was expecting this experiment to be a little more eventful. It's pretty much the same result every time. So I think instead of increasing the mass, let's increase the radius. It's probably going to be a sort of a long video. Pretty much like 40 minutes through, we're just adding stuff to the sun. Now we're going to see what happens when we make the sun bigger. And then we'll try to adjust the density. And of course make it hotter. See how it affects everything around it. So anyway, let's double the radius of the sun. Okay, now it's gotten a little bigger. How has that affected life on Earth? Not that much, surprisingly. Average temperature 44 degrees. Okay, oddly, having the sun bigger does not affect the Earth's temperature any. So let's do 3 times the size. How about now? Okay, it's going back and forth, but yeah, not much different. Okay, let's increase it some more. 4 times the size. Everything's the same as ever. But the sun itself, how's it looking? Oh! Somehow the core temperature dropped. It was usually around 16 million degrees Celsius. Now it's 4 million degrees Celsius. And the surface? Wow, the surface of the sun actually getting cooler. Now it's like 8,000 degrees instead of usual 9,000. That is crazy. It's losing its luminosity a bit too. It's like 0.97 instead of 1. How's it affecting life on Earth? It somehow increased the life likelihood on Earth. But it somehow decreased its similarity to Earth. That is weird. Okay. How about 5 times the size of the Sun? We decrease the core temperature some more, 3 million degrees Celsius. The Sun is getting colder as it gets bigger. Oh my god, how's it affecting Earth now? It's increasing the life likelihood on Earth. That is crazy. You know, I usually think the bigger the sun or star, the hotter it is. Granted, this is just our sun, but apparently making it bigger is making it colder. That is weird. I never heard anything like that. It doesn't seem to be affecting the orbits either. I thought they'd be like closing in a bit. Maybe they are, I can't tell. I guess I'll increase it some more just to see what happens. Oh, guys, getting colder. 2 million degrees Celsius, 2.3 to be exact. While the core is like 4 million degrees Fahrenheit. Granted, that's still hot. But given the size of the sun, oh my god, it's getting colder as it gets bigger. Now it's like 7,000 degrees Fahrenheit. And it's improving the life on Earth. I guess because everything's not boiling hot, it's giving life more time to thrive. That is crazy. It's making the Earth cooler. That's probably why. Minimum temperature 104, so I wouldn't be going to Antarctica anytime soon. The Earth's gotten a lot cooler. So Africa's finally getting a taste of cooler weather along with Australia. Though, given Australia, it'll probably give birth to more exotic and deadly species of everything. Okay. 8. 9. 10. It's suddenly becoming less dense. 4,500 degrees Kelvin. Yeah, it's still getting colder. Oh, 2 million degrees Fahrenheit in the core. Earth is benefiting from this. You think, well, the skies it's looking a little more lightish brown in the atmosphere. But it's doing well. That is crazy. It's given much of North America more snow and stuff. I know it's cold in Colorado, but not that cold. Parts of California, oh jeez. Even parts of Oklahoma. How about that? We're benefiting from the cooler temperatures, but for how long, I don't know. Like, it only gets up to like 53 degrees outside, which, hey, I'm okay with. Even around like low 50s, I'm good. It's good short weather for me. All this and it's still not jacked up the orbits of the planets. That's pretty interesting. But let's go and make things a little more interesting. Let's double this to 20 times the size. Yeah, we're getting a little more snow up in North America. That's kind of weird. We're still as good as ever. The sun, however... Oh, wow. The core temperature's at 6 digits. Granted, it's still hot, but... Yeah, when the sun's getting colder... That might cause problems in the long run, so let's speed things up a bit. I'm not going to increase the sun size that much now. It's getting colder. How's Earth? Okay, it's... still bouncing between 92.8 and 93%. Slowly dropping. Because, well, it's getting colder. Well, actually, it's gotten warmer somehow. Yeah, maximum temperature 73. Oh god, the sun's changing color. See, it's turning like a dark orange. It's getting colder. Is this what a star looks like when it's dying? I'm surprised Mercury still has a almost perfect orbit around the sun. Okay, life likelihood is slowly dropping. It's now down 92%. Back to where we started, pretty much. It's still getting colder. Let's just speed things up a little more. It's getting a little darker. That is crazy. Wow, 1282 Kelvin. So the server's like 1,849 degrees Fahrenheit. And yeah, the core temperature is still less than 1.5 million degrees. How's Earth now? Still surprisingly the same. With slightly less life likelihood, okay. Okay. Let's go ahead and double this. That's a 40 times the size. Still somewhat unchanged, even though, hold on. Due to the color of the sun. Now. Oh man, it's looking... Right, oddly, the, Earth itself is still fine. We still have a 90% chance of life likelihood here. And the surface, honestly, this would be an Earth I wouldn't mind living on. Though, turn off the light here. We're getting a little more ice around. Oh my god, look at all up here. Oh Jesus, I didn't realize that. I guess because the Earth is getting cooler. Oh my god, a lot of this, the North Pole's like completely frozen over here. But look at here. Around Northeast Asia here. Look, there's no ocean here. It's all frozen. Like parts of, like this upper part of Japan here. Yeah, Russia obviously. Yeah, still a lot of ice and stuff. The clouds. Okay, those were not clouds. Yeah, this is actual snow and stuff. Little snow in Saudi Arabia. Who would have thought? Oh my god, there's stuff here. Oh my god, Antarctica! Oh Jesus! You can't even see the actual continent of Antarctica anymore. It's like covered in like ice and stuff. Yeah, the North and South Poles are pretty much uninhabitable. But everyone that doesn't have like 12 inches of like warm clothing on. But look at all the ice. Like, there's no ocean up here above Canada anymore. Yeah, all Europe's frozen over. This is a Fimbulwinter of Viking lore. Jeez. Australia is oddly untouched. Well, where the increasing the size of the sun somehow benefits Earth, which I thought would be the opposite. But let's go and increase the mass a little more. Yeah, let's go and 186 AU astronomical unit. Let's double it. Oh Jesus! Oh my god! It just ate Mercury. Oh my god, there's no more Mercury. What about Earth? Somehow we're still alive. But we might be entering an ice age because, yeah. Average temperature 33 degrees. So I'd be leaving those faucets on if I were you. Look at that. What's on there? Is that where Mercury collided? Look at all these fragments around the solar system we just created. And again, it's getting colder. Like, Venus is Venus, yeah. Earth. This is crazy. I was expecting the Earth to be, like, incinerated as the sun got bigger, but no. It got colder. Because apparently as the sun grows in size, the temperature drops. And look, it's dropping a lot. Let's go and speed up things a bit more. Oh! It turned dark. Oh man. It's still hot. 720 degrees Fahrenheit on the surface. But the core... Oh man. How's Earth? Our life likelihood only dropped by 0.2%. What in the world? And how are we getting light? There's no light coming from the sun now. That is crazy. Look, there's no light. It's sort of about the same. There's no more snow in Saudi Arabia. And Antarctica's still pretty much... We made a little ice bridge from South America to Antarctica. So, yeah, if you want to take a trip over there, you can. Just be bundled up. How's the surface temperature right now? It's like... Oh god. Well, it didn't drop that much, but... hold on. I forgot to turn off the... Oh. That's why I had... Oh my god, the Earth's in eternal darkness. How are they getting power? There's no sun means there's no solar energy. I mean, there's still like an atmosphere and clouds and stuff, but without sun, without sunlight. Like, look at that. You see that big black mass over there? That's the sun. Like, imagine you wake up one day, like, your hours of sleep, you wake up, it's like, why is it still dark outside? And then you look at the news, like, oh, the sun lost all its luminosity. Oh boy, somehow we're still alive, though. Yeah, let's just, at the sun, let's just speed things up a bit. Let things go for a few hundred years. See, there's no more Mercury. How's Earth? Oh my god, how are we still alive? I guess humanity always finds a way to prosper. That's the beauty of humanity. We always find a way to make the best out of the worst of situations. I still don't see how that's possible. Imagine if there's no, like, sunlight, we'd all be dead. Like, we literally can't see anything, solar plants aren't working properly, all that stuff. Oddly, a happy ending here. Okay, regular sun back. Now, what happens if we increase the density of the sun? Let's double it. Let's zoom out real quick just to see the orbits and stuff. Did it affect Earth any? A little bit. We increase the temperature somehow. Let's just keep increasing the density a bit, see what happens. Still looks the same. The core temperature got hotter. Okay, so increasing the density of a sun makes it hotter, not the size. Let's go and, I don't know, you know, it's something plan on, you know, make it denser. Now it's like more dense. But, no significant, impact on our planet, oddly enough. Let's go and, make it more dense. How's it now? Okay, we increase it to 10,000 degrees. The core temperature is like, that much hotter. But how are we doing on Earth? Are we coping with the intense heat? Surprisingly, yes. Okay, we're gonna have to go crazy here. Look how much more dense I made the sun. Okay, the yaw's all crazy. The surface temperature's not that much hotter. The core temperature is like jacked up. But it's barely getting hotter on the surface. And you know, we humans are just chilling. You know, enjoying our 70-degree average. I'm cool with that. Well, that was pretty uneventful. Now let's try increasing the temperature. Okay. 9,000 degrees Fahrenheit. Let's double it. Oh yeah, we are cooking now. It just turned white, and the Earth is somewhat roasted. It's roasting, yeah, still. Yep. Okay, increasing the density of the sun does nothing. Increasing the size of the sun actually has benefits to Earth, but screws over Mercury, unfortunately. Increases the temperature of the sun. That's where you get some results. And increasing the mass of the sun just essentially turns it into a black hole. Increase it enough and it will be a black hole. Yeah. Surface of the sun, 11,000 degrees Kelvin. Let's double it. Mercury's like glowing hot now. Well, that's something. Select Mercury here. Yeah, it's pretty much crematoria from the Chronicles of it. One side's always cold, the other side's like piping hot. Kind of weird lighting here. Like a little bit of red here, but was it face the sun? Yeah, you don't have a snowball's chance in hell. Only this side will be cool. Oh, is it tidally locked? Hold on, wait. Oh no, I thought it was tidally locked to the sun. Those that don't tidally locked means that one side is always facing the sun, and the other side is not. That means that one side will always be hot, and the other side will always be cold. No, it's spinning. Wait, I think it is tidally locked. Okay. Anyway, how's Earth? Yeah, pretty much all the stuff evaporated, and yeah, nothing but amoebas living on Earth now. Okay. Try to click on the sun, damn it. Okay. There we go. Okay. Let's increase this more. Okay, the asteroids are all glowing. We get hotter. They're glowing some more. Yeah, more hotter. Okay, did we? Oh, it turned the asteroids into clouds now. Oh, Jesus, Mercury! Oh, Jesus, Mercury, look at this. Oh, sweet Mercury, what is happening here? Half of the planet is like glowing white. I swear it looks like it's tidally locked to the sun. How is the surface on here anyway? Oh, yeah. Yeah, I don't think SPF 100 is going to be enough for that. Hey, caramba. How's Earth? Yeah, we're not doing much better. We are not doing much better. Yeah, there's pretty much nothing left on Earth. We are literally cooked. The entire planet's glowing. Like we're now like a borderline sun. Look at all these clouds. We're in this AORUS system now. Jupiter's glowing. And Saturn, Uranus. Yeah, it's red hot. Yeah, lay off the spicy foods for a little bit. Okay. Let's just go thermonuclear. god, look at these glowing clouds. This is oddly beautiful. Not gonna lie. Granted, it's a sign of the end times, but hey, gotta have a little bit of beauty before all the destruction, you know. Look how much it's glowing, Jesus. 56 million solar luminosity units or whatever. Wow. I'm not gonna lie, this is oddly beautiful. Let's double it. Oh, it's... Someone becomes even more beautiful. 1,000,000 degrees Kelvin. Everything's like bright blue. Yeah, Mercury's... Yeah. Earth's pretty much a portable sun now. There's nothing but iron and silicate. There's like nothing on Earth now. Yeah, the sun... 1,000,000 degrees Kelvin, or... You know... Almost 18 million degrees Fahrenheit. Okay, let's double it. Now everything's turned purple. And it's glowing even more. We've got 160 million degrees Kelvin. Look at all the clouds that have formed from all the different asteroids and stuff that once orbited the solar system. You know, even though there's like nothing alive in the solar system now, this is amazingly beautiful. That is crazy. You know what? I'm going to save this, actually. I'm going to save... Okay, my Sims. I'm going to save this as... The Eye of Soul. Okay, this is what happens when the sun reaches 16 million degrees Kelvin. There is virtually no life in the solar system, but the resulting clouds from all the disintegrated asteroids, as well as the glowing hot planets, well, glowing hot lifeless planets orbiting the sun, is oddly beautiful. I inadvertently created my own, like, celestial body. It's not only the solar system, it's the Eye of Soul. That is crazy. Let's double it some more. 32 million degrees Kelvin. No. Is that... Oh. Well, good thing I saved it, because, yeah, making it too hot and the sun will just disappear. There's no more Mercury. Earth is now a lifeless husk of a planet. You think Gray still plays would be proud? I think he would. There's nothing left on Earth, but hey. Okay, we'll do one more thing, then we'll call the video. Okay, so we increase the mass in many ways. We increase the radius. We increase the density, which did nothing. We increase the surface temperature. What about the rotational period? 26 times a day? What if we doubled that? Does that affect anything? On Earth... not really. It rotates 5,200,000 times a day. Doesn't affect anything though. Okay. What if it didn't spin at all? Yeah, what if it doesn't spin at all? Nothing, really. Okay, well, rotational period doesn't do anything. Speed! Here, I'll make the... Oh my god, the sun's moving. I didn't mean to turn on these graphs. Okay, the sun's like moving now. And Mercury's trying to... Mercury's trying its best to like stay within orbit, but everything else is like going out of whack. Somehow we increased the life expectancy on Earth by doing that. Oh, it's how's life now? Okay, a little worse. Let's increase it some more. Oh god, it's shooting away so fast. Oh my god, Jupiter's like dark now. Because there's no sun around it. Where's Earth? There's Earth. Binary of Mercury, what? Okay, because there's no sun now. The sun just left the solar system. There's no light now, so... Oh yeah, Earth's pretty much a ball of ice now. Okay. Well, that's something. Somehow there's still life on Earth. We have no sun. But life still prospers. Well, I think that'll do it for this video of Universe Sandbox. They were on my longer videos, didn't expect it to be this long, but touring around the sun and stuff like that. Man, that was quite an experience, not gonna lie. Anyway, this is I'm Giving Caleb signing out. You have a good day.